Pause the video now, guys, and try question number 1. Okay, an 8-mark question looking at implicit differentiation. Okay, so pause it, have a look. Okay, attempt and try the question. Okay, show your full workings, and then come back and press play and check your answer or answers along with me. Okay, question 1. A curve has the equation 2x squared minus 3xy plus y squared equals 12. Part A. Find an expression for dou by dx. Okay, so rate of change. Okay, so step 1. So we differentiate, okay, each component separately. But here's the key: whenever I differentiate a function of y, I just stick on a dy by dx at the end of it. Okay, just do it. So 2x squared here, that goes to 4x. Okay, the 3xy. So I'm going to use the product rule here. So product rule here. So differentiate 3x, I get minus 3, so it becomes minus 3y. I differentiate y, that goes to 1. So I'm going to have minus 3x dy by dx, okay? So remember, whenever you differentiate a function involving y, you always stick on a dy by dx at the end of it, okay? And then y squared goes to plus 2y dy by dx, okay? And it's always equal to something, okay? Yeah, so we differentiate 12, that's just a constant, so it goes to 0, okay? So that equals 0, okay? I'm now going to rearrange this equation, okay? So I've got all my dy by dx terms on one side and all my non-dy by dx terms here on the other side, okay? So I'm gonna add 3y here and subtract 4x, okay? So I'm gonna have 2y y by dx, subtract 3x dy dx, so subtract 3x dy dx. That's equal to, guys, that's equal to 3y minus 4x. Okay, remember that when obviously the sign changes when you move it over the equation. Okay, the sign changes sign. Okay, or the sign just actually becomes opposite. Okay, I'm now going to factorize that dy by dx. I'm going to have dy by dx brackets 2y minus 3x is equal to this. Dividing both sides of my equation by 2 minus 3x, okay, we're going to get that dy by dx, guys, is equal to 3y minus 4x all over, okay, 2y minus 3x, okay, and this is what I call an implicit function, okay. So it's implicit because I cannot rearrange the original equation here in the form y equals f of x. It's in the form x equals f of y, okay, with some f of x bits to it, okay. So that's why we do implicit differentiation, okay. That's part A done. Okay, what about part B? Find an equation for the normal to the curve at 1, 2. So I'm going to sub in here x equals 1, y equals minus 2 into dy by dx to work out my tangent gradient. And then I'm going to do the negative reciprocal, okay, of that. So work out the value for m first, okay. So I'm going to have 3 times minus 2, so that'll be minus 6. Minus 4 times 1, yes, that'll be 4, so minus 4. All over 2y, so that'll be minus 4. And then minus 3. So we're going to have minus 10, okay, over minus 7. Okay, the 2 minus, they just cancel, so I get 10 sevenths, okay, or positive 10 sevenths. The negative reciprocal of this will be minus 7 tenths, guys, okay? So you flip it and then you negate it. So it becomes minus 7 tenths. So it'll be y minus y1. So y minus y1 is equal to minus 7 tenths brackets x minus x1, okay, where y1 and x1 are your two coordinates, okay, that you're looking at. In this case here, it's 1 minus 2. So x1 is 1 and y1 is minus 2, okay. Remember, if you subtract the negative, the positive, okay, I'm going to times up by 10. So I'm going to have 10y plus 20 is equal to minus 7x plus 7. And I'm going to add 7x to both sides, okay. And yeah, okay, and obviously minus 20. I'm going to have 7x plus 10y, okay, is equal to minus 13. Okay, I'm leaving here obviously in this comments here, okay, but in the exam, guys, yeah, okay, remember to obviously follow your exam board, okay, the way they want to obviously as your answer. So write it in y equals mx plus c, or ax plus by equals c, or ax plus by plus c equals 0. Okay, I'll put it in this form here because obviously it's a bit more neater. Okay, of course I can write it as 7x plus 10y plus 13a equals 0. Okay, like complete like neatness if you like. Okay, but either way, your answer should suffice. Okay, but make sure that you put it in the form they want it in. Okay, whether it's OCR A level maths, OCR MEI B, or OCR B MEI. Okay, or AQA A level maths, or EDEXCEL A level maths. Okay, but this is a super hot topic that is likely to come up here on tomorrow's paper. Okay, so revise implicit differentiation, and the key takeaway is as follows. Whenever you differentiate a function that has a y in it, you always stick on a dy by the x at the end of it. Okay, thanks for watching. Take care. Good luck for tomorrow.